Hi, this is Yaman Goda, studying in Sri Venkateswara College of Engineering. Let us discuss about Introduction to Quicksort. Quicksort is a popular and efficient sorting algorithm used to arrange elements in a specific order. It was by selecting a pivot element from the list of pretending the list into two sub-lists, one with element less than the pivot and the other with elements greater than the pivot. Time complexity of Quicksort. The time complexity of Quicksort is a critical factor in understanding its performance. In the best case scenario, which the pivot element is chosen optimally, Quicksort has a time complexity of O n log n, making it efficiently algorithm. However, in the worst case scenario, when the pivot element is consequently chosen, poor complexity can degrade to O n square, which is less desirable. This highlights the importance of pivot selecting in quicksort overall performance. Best case scenario O into n log n. Quicksort is known for its efficient performance, particularly in its best case scenario, which has time complexity of O into n log n. This means that as the size of input array increasing, the time required to sort the array grows logarithmically, make quicksort a high scalable algorithm. This best case scenario occurs when the pivot element selected during the pretending process conti- pretending process divides the array into two equal or near equal avals, allowing the recursive calls to be made on smaller and smaller subarrays. The O into n log n time complexity of the best case scenario is achieved due to the efficient nature of pretending process and the recursive nature of the algorithm by respectively dividing the array into smaller subarray and performing the sorting process on this subarray. Quicksort is able to achieve a highly efficient sorting performance even a large input sizes. Worst case scenario. In the worst case scenario, the quicksort of algorithm can have time complexity. This occurs when the pivot element selected in each step is always the smallest or largest element is in the unsorted protection. This results is the algorithm respectively pretending the array into two very unbalanced subarrays, leading into high number of comparisons and swaps. This scenario is mostly likely to happen when the input array is already sorted or reverse sorted, reducing the effectiveness of quicksort algorithm. To this issue, it's important to choose the pivot element carefully, such as selecting the median value or a random element from the pretension. Additionally, techniques like randomized pivot selection or the use of median of 3 can help improve the algorithmic performance even in the worst case of scenario. Protection the array. Choose pivot element. The first step in the quicksort algorithm is to choose a pivot element from the array. This pivot element will be used to partition the array into two sub-arrays, one with element less than the pivot and another with element greater than or equal to the pivot. Rearrange the array. Once the pivot element is chosen, the algorithm will rearrange the element in the array such that all elements less than the pivot are on the left side and element greater than or equal to the pivot on the right side. Recursive calls. After pretending the array, the quicksort algorithm make recursive calls on the two subarrays. Processing continues until the entire array is sorted into ascending order. Choose on the pivot element. Random selection. first and last selection, medium of 3, recursive calls and protection. Protection the array around a pivot cells. Compare. Recursive sort that the left and right protection combine. Merge the sorted protection back together. The power of quicksort less into recursive nature. Once the array is protection around the pivot element, it makes two recursive calls. One to sort the left protection and one to sort right protection. Divide and consequent approach all quicksort to efficiently tackle larger arrays by breaking them down into smaller. Advantages of quicksort effectiveness. Quicksort has a time complexity on of O into n log n on arranging making an average making it one of the most efficient sorting algorithm available. This making it a popular chosen for a sorting larger data sets where performing is crucial. In-place sorting. Quicksort is a Quicksort is an in-place algorithm, meaning it can sort the data without requiring additional memory space. This mark this makes the memory efficient and improvement conditionary for sorting large data sets. Simplicity. The quicksort algorithm is relatively straightforward to implement with a simple recursive structure. This makes it easy to understand and implement a valuable trait for developers working on sorting based applications. Parallelization. Quicksort can be easily parallelized, allowing for efficient sorting on multi-core systems. This makes it is a powerful tool for handling large-scale data processing tasks. Limitation of Quicksort. Sensitively to pivot selection, Quicksort performance heavily depends on the choice of the pivot element. If the pivot is not selected carefully, it can lead to an unbalanced prediction, resulting in a worst case scenario with a time of complexity potential of stack overflow. In the case of highly unbalanced prediction, the recursive calls in Quicksort can lead to a very deep call stack, potentially causing a stack overflow error, especially in systems with limited memory. Insufficient for small arrays. For small arrays, the overhead of the pretending process and recursive calls can outweigh the benefits of quicksort, making it less efficient compared to simple sorting algorithm like inserting sort. Quicksort is the order Quicksort is the other implement important sorting algorithm that is based on divide and conquer approach. Unlike merge sort, which divides its input element according to their position in the array, Quicksort divides them according to their values. We already incorrected these ideas of arrays protection in selection where we discussed the selection problem. The protection is a arrangement of arrays elements so all the elements to left sum as and less than are equal to as and all the elements to right side as are greater than it. Conclusion and summary. In the conclusion, the quicksort algorithm is highly efficient sorting technique with a best case time complexity of n log n, making it an excellent choice for many practical application. While it can have worst case scenario of O n square, it this can be mitigated by carefully selecting the pivot element. Overall, quicksort advantages such as its speed, simplicity, and place operations make it a widely used and valuable tool in the of data sorting manipulation. Thank you.